Okay, so this is not in the original problem set, but I thought I'd go through it anyway, because it's something that's sort of interesting. It's the root of x plus 1. It's not a perfect square, by the way, but the method still works, right? Even though x plus 1 may not be a perfect square, it still works. However, it is hellish. It goes on forever, right? So I want to point out that x plus 1 is identical to 1 plus x. So what I do, it's really the process of completing the square, right? So what I do over here, I hope you realize that, 1 plus x minus 1 squared is still going to be x, all right? And then I go on, and on, and on, and on. And when you do this over here, every step that follows, right, every step that follows comes from the prior step. It's all about completing the square now, all right, all about completing the square. Now, what I mean by completing the square, if you took, the 1 plus, I still have the 1 plus x, but I'm doing minus, what would you get there? 1 plus x over 2 would be 1 plus x plus x squared over 4. So then basically I get this line, and then I get this line, and then I get this line, and I think you get the idea. It goes on forever and ever and ever, and really is tough, all right? So bottom line is we get what's known as a series expansion for the square root of x plus 1. Where are we getting that from? Right up there. And what are we seeing over here? We're seeing this, and by the way, it goes on forever, but you see a pattern. I'm not sure it's a great pattern, but you do see a pattern over there, and this is the pattern you're seeing, all right? It's a tough pattern, though. I'm not saying that you want to keep computing that pattern, but you could do it. We have better ways of doing it, and that'll come later in the semester. We'll be able to expand this thing quite easily. Right now, that expansion was difficult. So how many terms we get? 1, 2, 3, 4, 5. This goes on forever. It's infinite. We have better ways of expanding, though. That comes later, not now. Thank you.